Imagine you are standing outside on a clear day. The sky is blue, the sun is warm, birds are singing somewhere nearby. Everything feels safe, everything feels permanent, everything feels exactly as it should be. You cannot see what is protecting you. Right now, surrounding the entire planet, there is an invisible shield. It extends tens of thousands of kilometers into space. It is generated deep in the Earth's core, in the churning liquid iron that surrounds a solid inner core, rotating as the planet rotates, generating an electromagnetic field that wraps around everything. This field has been here for at least 4 billion years. It has protected everything that has ever lived on this planet. Without it, life as we know it would not exist, and it is weakening. Not slowly, not in some distant geological future, right now. Over the last 150 years, since humans first started measuring it, Earth's magnetic field has weakened by approximately 10%. 10% in 150 years. In terms of geological time, that is almost instantaneous. Before we go further, if this video makes you see the world differently, if the ground beneath you feels slightly different after watching, hit that like button and subscribe to Cosmos Insight. Every subscriber helps us keep making these documentaries. Now, let's go underground. The magnetic field is generated in Earth's outer core. Approximately 2,900 kilometers beneath your feet, the planet is liquid metal, iron and nickel, heated to temperatures comparable to the surface of the sun, churning in slow convection currents driven by the cooling of the inner core and the rotation of the planet itself. This churning liquid metal acts like a dynamo, a natural generator producing the electromagnetic field that surrounds the planet. The field is not uniform. It is not a perfect sphere of protection. It bulges at some points, thins at others, shifts constantly. The magnetic poles are not fixed. They wander, sometimes dramatically. The North Magnetic Pole has been drifting toward Siberia at an accelerating rate for decades. Scientists have had to update navigation systems to account for its movement. But something more significant than pole drift is happening right now. In a region of the South Atlantic Ocean, stretching from Africa to South America, there is a place where the magnetic field is dramatically weaker than everywhere else. Scientists call it the South Atlantic Anomaly. It is a vast dent in the planet's protective shield, a region where the field is so weak that satellites passing through it experience hardware failures and data corruption from cosmic radiation that the weakened field cannot deflect. The South Atlantic Anomaly is growing, and the field within it is weakening further. But here's the problem. This has happened before, not exactly like this, but the field has weakened dramatically before, and we know what followed. The Earth's magnetic field reverses, the North Pole becomes a South Pole, the South Pole becomes a North Pole. The compass that has always pointed roughly north would point roughly south. This is not speculation. It is documented in the geological record. Magnetized minerals in ancient rock formations preserved the direction of the magnetic field at the time they solidified. And those ancient rocks tell a story. The field has reversed hundreds of times in Earth's history. The last reversal happened approximately 780,000 years ago. The average interval between reversals is roughly 250,000 years. We are overdue, and here is where everything changes. A reversal does not happen instantly. It takes anywhere from 1,000 to 10,000 years to complete. During that process, the field does not simply flip, it weakens. Dramatically, it becomes chaotic and fragmented. Instead of one coherent dipole field wrapping around the planet, the field breaks into multiple smaller patches, wandering, inconsistent, offering only partial protection in some regions and almost none in others. But it gets worse. During a reversal, or even during a significant weakening without a reversal, the consequences for life on the surface would be severe. The magnetic field is not just a navigational tool. It is the reason we have an atmosphere thick enough to breathe. It is the reason liquid water exists on the surface. It is the reason the sun has not stripped away everything that makes this planet habitable. The solar wind, the constant stream of charged particles blasting outward from the sun, is deflected by the magnetic field. Without that deflection, those particles hit the upper atmosphere directly. Over time, they strip it away. This is not theoretical. We know this happened to Mars. Mars once had a magnetic field. It collapsed. The solar wind stripped its atmosphere. The oceans evaporated. The planet died. Earth is not Mars. Earth is larger. Earth's geological activity is still strong enough to maintain a magnetic field. A weakening or reversal does not mean Earth will become Mars. But during a reversal, the reduced field means more solar radiation reaches the surface. The ozone layer we occupy, which depends partly on the magnetic field for protection against high energy particles, would be more vulnerable to damage. Ultraviolet radiation reaching the surface would increase. Cosmic rays, high energy particles from outside the solar system, would penetrate deeper into the atmosphere. The effects on biology would be real. Increased cancer rates, damage to ecosystems sensitive to ultraviolet radiation, disruption to the navigation systems of migratory animals, birds, whales, sea turtles, that rely on the magnetic field to find their way across the planet. And the effects on human civilization would be catastrophic in ways that have nothing to do with biology. And here is where everything changes again. The technology problem. Every satellite in orbit around Earth operates within the magnetic field. GPS systems, weather satellites, communication networks, military surveillance systems, every piece of technology that depends on electronics operating in space exists because the magnetic field provides a baseline of protection against the radiation environment of space. During a significant weakening or reversal, the radiation environment that satellites operate in would change dramatically. The Van Allen radiation belts, the zones of trapped charged particles that surround Earth, would destabilize. Satellites that operate within them would face significantly higher radiation doses. Electronics would fail, missions would be shortened or terminated. The global positioning system, which every phone on the planet uses for navigation, which shipping uses for logistics, which financial systems use for transaction timing, which aviation uses for routing, depends on satellites. If those satellites begin failing faster than they can be replaced, the consequences cascade through every system that depends on them. The power grid is vulnerable in a different way. During geomagnetic storms, which are already a problem during solar maximum, fluctuating magnetic fields induce electrical currents in long conductors like power lines. These geomagnetically induced currents can damage or destroy transformers. The larger the transformer, the more vulnerable it is. The more vulnerable the transformer, the longer it takes to replace. Large transformers are custom built and can take months to years to manufacture. A significant geomagnetic event during a period of weakened field could damage power infrastructure across entire regions simultaneously. The recovery would be measured not in days, but in months or years. But that's still not the worst part, because the most unsettling thing about the weakening magnetic field is not what we know. It is what we do not know. We do not know if the current weakening is the beginning of a full reversal. We do not know if it will stabilize and recover as it has done at other points in Earth's history without a reversal occurring. We do not know how long the current weakening will continue or how severe it will become. The geological record tells us reversals happen, but it does not tell us exactly when the next one will occur or how severe the transition period will be. The European Space Agency's SWARM mission, 3 satellites flying in formation to map the magnetic field in extraordinary detail, has been monitoring the field since 2013. The data it has returned has refined our understanding of the field's structure and evolution, but it has also deepened the uncertainty. The South Atlantic Anomaly appears to be splitting into 2 separate regions of weakness. The field in the northern polar region is showing unusual activity. The behavior of the field is more complex and less predictable than simpler models suggested. We are watching something happen that has happened hundreds of times before in Earth's history. And we are watching it for the first time with instruments precise enough to see its complexity. And the more precisely we see it, the less certain we are about what comes next. There is something about the magnetic field that is almost impossible to fully process. It has been here longer than the oceans, longer than the continents in their current form, longer than the first multicellular life. For 4 billion years, through every mass extinction, every ice age, every collision with asteroids that reshape the surface, the magnetic field has been there, fluctuating, reversing, recovering, but present. A constant that predates everything we think of as permanent about this planet. Every creature that has ever lived on Earth has lived inside this field. Every ancestor you have ever had, going back to the first single-celled organisms in the ancient ocean, lived their entire existence within this invisible electromagnetic envelope. It has never been absent, not once in the history of life on this planet. And right now, at this moment in history, for the first time, we have the instruments to watch it change, to measure its weakening in real time, to see the South Atlantic Anomaly growing, to track the pole moving towards Siberia faster than it has moved in recorded history. We are watching something ancient and fundamental shifting beneath our feet. Something we never needed to worry about before because it was always there. Something we built an entire civilization without ever thinking about. Something that is, quietly and invisibly, becoming less of what it has always been. Here is what stays with you. The sky you see when you look up is blue because of the atmosphere. The atmosphere is here because of the magnetic field. The magnetic field is here because of the liquid iron churning in the core. The liquid iron is churning because of heat left over from the formation of the planet 4.5 billion years ago and the decay of radioactive elements within it. Everything you can see and breathe and touch on the surface of this planet, every living thing, every body of water, every breath of air, is a downstream consequence of something happening thousands of kilometers beneath your feet that you will never see and cannot feel and have never had to think about until now. The invisible shield is weakening. We do not know why. We do not know if it will recover. We do not know if we are watching the beginning of a reversal that will take thousands of years to complete, or a temporary fluctuation that will stabilize within centuries. What we know is that for the first time in human history, we are watching it happen. And for the first time in the history of life on Earth, there is a species on the surface that depends on technology that the field protects, and that species is us. Look up at the sky. The blue is still there. The protection is still there. Diminished, shifting, uncertain, but still there. For now.